Okay, so now we just need to practice this skill. So we've got here a reaction for which the enthalpy change is unknown, and a couple of reactions that we've been given, different ones, for which their enthalpy changes are known. So I've just written the one that we're trying to find out about along the top here, and then we just need to look and see, well, what is it in these equations for which the enthalpy changes are known that kind of corresponds to our one that we're trying to find out about. So you're looking for a kind of a key substance that matches. We've ignored oxygen before, and again we're going to ignore that here. There is no N2 in this equation, but look, there is nitrogen monoxide. It's up here as a product. Okay, sorry, it's here as a reactant over here, apologies, and it's here as a product in this reaction. So what we're going to do is we're going to see, well, how does this reaction fit into our cycle? We've already got this one written along the top here, so we need to kind of fit these two in to make that kind of triangular kind of cycle. So this one is going to fit in because NO is a product of this reaction. So we're going to need to put an arrow going up. Okay, we know it goes up because on the end of the arrow, that's where we write the products. Okay, so the arrow goes in this direction, so that we've got this as a product, like it is here, of the reaction for which this is the enthalpy change value. Okay, and the reactants of that reaction, okay, the nitrogen and the oxygen, are written down here at the beginning of this arrow. So we're now getting what looks a bit like a Hess cycle. We just need to complete it by fitting in this third equation. Okay, now actually it's already in there. We just don't realise it. We just got to spot how it fits in. Well, nitrogen and oxygen, we've already got written down here, look, can make NO2. And look, nitrogen and oxygen, NO2. Okay, so those substances are actually already written. We just need to put our arrow in, and it's got to go in this direction because we're starting with those and making that. So the arrow shows that we're starting with those and making that. And on this arrow, we can write the enthalpy change that corresponds to that particular change. Now we just need to spot which sort of route round our cycle we go. This is the start because this has only got arrows going out of it, and this is the end because it's got arrows going into it only. So our two routes are route 1 and route 2. And we remember that route 1 is equal to route 2 in terms of its enthalpy changes. So we've got 180.5, that's this one, plus our delta HR is going to be equal to the 66.4. And if you rearrange that to get delta HR, you get minus 114.1. Okay? Notice I didn't multiply these by anything because these values correspond to the balancing that's in this equation. Okay, so if we look at what we've got in here, it actually, that 180.5 was for producing 2 lots of NO, and that's what we're producing in here. Okay, because that value corresponds to that equation and the balancing matches. Okay, same for this one. This 66.4 corresponds to making 2 lots of NO2 because we're told that it does by when they wrote that. And that's what we're making here. So no need to do anything different to the number or scale it up or multiply it by anything. Okay? Now the good thing about this for you guys is that actually you don't need to be able to construct these cycles. You just need to be able to use them. So if you're given one of these, you need to know how to do the calculation, but they actually won't expect you to make your own. Okay, but I think it's useful to see it. If you have a go at the next one, just a sort of a hint there before you have a go at it, if all you were provided with this table, okay, obviously you could use your other method because you've been given enthalpy changes of formation and the other method is easier, but if you were asked to do it via a cycle, or if they they were leading you into that, then remember that if you've got enthalpy changes of formations, you can write equations for those because we've done that. So what I've done there is I've just written the equations for the enthalpy changes of formations. So those are the equations that those values correspond to. So why don't you just pause and try and figure out how to do that example. And there's the answer to that one. Now for this one, just to point out that here, look, there's a 2 there, but because this is a formation, that number corresponds to making 1 mole of CO2. So for this one, we would need to multiply that number by 2 and then do that in our calculation. Okay, so the roots here were that one, it's root 1, and that one, root 2.